Hey YouTube, it's Dimitri, and today we're going to talk about what is quantitative finance research here. So I get quite a few questions here on Dimitri, I am a PhD, I want to do research, or Dimitri, I'm a mathematics master's or PhD student, and I just want to do math. Is this going to be a good fit for me? And I think you need to understand kind of the scalings and the perspectives here on what we talk about when we say research, because you could be doing one of many things across this kind of range here, we're going to call it. So let's just dive on in here. And to start with here, I'm going to say we have academic research. And what I mean by this is not that you're necessarily publishing in any sort of journals, but academic research is typically going to be you want to discover something new. I'm going to put here unique discovery. And when we think about things like this, we start to get really excited from reading all quantitative finance, and you start to think about things like the Black-Scholes. You might be thinking of other sorts of things as well, like very academic-y, pure mathematics or applied math in quant finance, where they're really, really in-depth, I'm going to say just academic topics here, right? And then we're going to have this scale here, and this scale is going to go all the way over. And I'm going to call this model development. And what I mean by model development is somebody's going to say, come in here and build a model to model X. So let's use my most common example here. We're going to model something like probability of default, PD. We're going to just jump right into using logistic regression, or perhaps maybe a decision tree, and we're going to model this out. And we're going to quickly go through a bunch of programming, and this is going to require, just R or Python or SAS or something, and we're going to program this out, and we're going to build some sort of model here. I'm going to say this is kind of like a repetitive process, and more specifically on this is going to be something that is it's very defined. This is going to be a defined problem here. So as my example was probability of default, and we use something like logistic regression. And more specifically, it was just something quite simple. We're going to put simple in air quotes here because most people don't know what they're doing just because they code things. But we're going to say simple coding. Okay, so let's dive into where we see these sorts of things and kind of how these are the same thing, but often you end up doing a lot of this here, which is going to be model development. And I think a lot of PhDs will be quite disappointed in realizing we are not doing a whole lot of academic research, though it kind of comes up. And I'm also going to put here, your research is proprietary. So I have done many really cool things at banks, things that I thought were quite novel, unique, groundbreaking, things I've never seen done, things that I searched academic papers for and could never find anything on. Ended up coming up with entire frameworks to solve interesting problems. And then years went by and I never documented it. I didn't write papers on it. The firms I were at, they didn't even understand it was of even value. They just thought it was some method or process, and then they just throw it out the window and they don't like it. And then you move on. So there's kind of this downside, this little negative connotation here to quant finance. And this is a big difference in play between kind of the firms that you see. So some firms will really emphasize long-term, meaningful academic research. Other firms are going to be more on the side of just like model development as fast as possible. And there's going to be some in the middle, but I tend to find most are going to be on one end or the other. You're always going to have some sort of mix with this, of course, because you need both of them. So let's also talk a little bit about kind of the use cases for these and why these things happen. Academic research is really a long-term game here, or a long-term kind of strategy. You think that you want to invest a ton of money and time and resources in employees. You have to realize you're not going to get much out of them. In the short run, it could be them writing papers, researching, doing ideas. You could have a whole team of people doing this, and you could have failure after failure after failure after failure, and then all of a sudden, there's a breakthrough from somebody on the team. Something of value comes out, and you end up with some really, pretty diamond here that comes out of this strategy here, this piece, this groundbreaking technology that's really going to set you apart and change things. When we look though at the model development side here, this is going to be short-term gains because the firm, or I guess game gains too. You're making money here. Short-term gains in the sense that you're trying to make some sort of profit. You're trying to get to point A to point B as fast as possible. You're just running a business here. So let's look at a few examples, and then I'll talk a little bit about why we kind of have these two pieces. Okay, so let's boil this down here to what we're really doing here and why we kind of call model development and research kind of the same thing. And hedge funds call it research because it's more sexy and you can get, more PhDs to come over and it's fun and exciting. And then banks just call it model development. We just build models. And no, these are not quant devs. We're not optimizing code. This isn't HFT world usually, which is kind of more of the quant dev space. I'm talking real research and real model development here. The real difference is we're just doing math. Like, it's taken me a decade to understand that we're just doing mathematics, and we're going to define some sort of problem. And realistically, the real world is, so when you go to like a financial engineering program, I think a lot of them are kind of, I don't know. They frustrate me. I don't think they focus on the core skills of actually solving problems here. When you go through things like the Black-Scholes equation and you do I'm going to do the derivation of this, that, and the other, that's a waste of time because to be honest with you, most parts of my life, I'm not actually deriving and doing math. Like someone assumes you're going to give me a math problem and then I'm going to solve this problem, find the integral of this function or something, or, use stochastic calculus to X, Y, and Z. No, that's not very common. Sure, there are areas that use this more so than others, but the hardest problem with this is more or less kind of like a pure math thing, which is defining the problem. Okay. A business person will come in and say, I want A, B, C, and D, and you need to come up with a solution. And then you find out later that it's not A, B, C, and D they wanted. It's also A, B, C, and D with E, F, G, H, I, J, and K, which are all these features and functions and pieces that need to be incorporated that your model, I'm going to call it a model here, your math equation can do. That's all we're trying to do here. So let's give an example of this. Let's go back to that PD model. PD is just, find probability of default. And so now you have to say, okay, well, what does that mean? Right? I mean, what is a default? So you can define default many different ways. You can have 60 days past due, so DPDs, within, I don't know, let's say 120 days. You could define it as 90 days DPD, within 120 days. You could say ever. So these are, 90 days in this. You could say ever 60 days past due. So essentially a loan could be alive for 2 years, 3 years, or 4 years or something, then all of a sudden goes 60 days past due. We're now going to flag that as a bad. So give me a second, I'll get to that. You could have, ever 90. Typically when you hit 120, it's just called charge off. So, you could say just charge off, which means the account hit 120 days past due. And then we just collected the money. We went and repoed the car. If it's a house, close out the house. Credit cards are late, whatever. I don't know. These typically use for auto financing and mortgages. I work in auto finance if you're curious. But essentially all of these sorts of things here are going to generate some sort of column. I'm going to call it the dep var, the dependent variable. And it's just going to be zeros and ones. And what we're actually modeling here is not getting 0 and 1. I'm going to drive this home for all you data scientists out there. I don't care if it's 0. I don't care if it's 1. I don't even care about the accuracy of 0 and 1. Because the reality is I'm predicting, if we go back here now, I'm predicting the probability. The probability is not actually known. It's something I can't even see when I'm modeling, right? I know that the account was 1, meaning it was bad, so it hit one of the, whatever definition we chose. Let's just pick, I don't know, ever 60 days past due. And then I can go through all these accounts and go, this one was bad, it was 1. This one is good, it was 0. But the reality is, when you have some sort of prediction that comes out of this, it's going to be like 0.1013, 0.7589, 0.5216, yada, yada, yada. The predictions are a probability, and we're not actually going to measure this. I'm not going to go down this rabbit hole. This is why we use AUC. We don't use a confusion matrix, because you can test every possible threshold possible, and then you can have a strategy team who does all the thresholds and all that. But to get to this, what we're going down a rabbit hole here, but what we're trying to do is we're trying to find f of x such that it's some sort of math equation that is going to be equal to the probability of default, and I do not know what goes in this box. So there are two pieces here when you solve things mathematically, which most of you probably don't look at this if you're a data scientist or a quant, statistician, whatever. But if you do a lot of math, you start to think more mathematically. The math question here is find f of x such that we have a solution which, in many cases, so if you're curious on this, it needs to rank order. What this means is that if I tell you that you are, we'll use FICO for example, let's use probability of default. If your probability of default is 0.5, those that are priced at 0.5 should have an actual bad rate, meaning everyone that looks that exact same with a 0.5 score should perform significantly better than somebody that has like say a 0.7. Right, so we're trying to rank order the risk. You can think about this in terms of FICO as well. So a scorecard, which is kind of what this is doing, those that have like say an 800 FICO should perform significantly better than those with like a 400 FICO, right? That's rank ordering, but you have to typically create clusters and groups of people. We do them deciles, and it's a whole thing. But you want to see that every 10% of the population that you modeled or you're testing on has rank ordering. The other thing I'm going to talk about is accuracy. And I'm just going to say accuracy in the sense of AUC, area under the curve, the ROC curve. All we're doing is separating out the true positives and false positives. And when we have those true positives and false positives on a little axes here, so I'll just draw it out for you real quick. You have like true, positive, and false positive. You have a 45-degree angle right here. And essentially, if you do better than this, meaning you have better than a random guess, so this is actually right here. So 45 degrees equal to 50% accuracy. You have this line that looks something like this. And essentially what it's saying is that your true positives and false positives, as you move the threshold across this axis, this is the separation or gap that we're getting. This is the lift of this scorecard here, this model here. So anyways, too much credit for you guys. But when we go back here into the PD portion, what we're trying to figure out is the structure and the coefficients. And what I mean by this is when we go into structure, we have f of x. And the question is, how big is f of x? So I already know for the most part that this needs to be a logistic regression. So I don't need to go and do a bunch of extra research and find new methods and overcomplicate things. Now you could, that would be an academic pursuit. That'd be more of the in-depth process here. But we're not going to do that. I know it needs to be logistics. I know this needs to be 1 over 1 plus e to the negative x, where x is going to be equal to some sort of linear regression here, where it should have something like alpha plus beta 1 x1 plus beta 2 x2 plus ... I don't know how many terms I'm going to need, all the way out to beta n x of n. So I know this is my problem I'm solving, but I don't know the structure of it, right? How many pieces do I need here? How many variables in this model do I need? Now, if you rewind to go into time series, it's a whole other project not related to this. When you do something such as time series, I use the Box-Jenkins approach a lot. I used it exclusively when I was doing CCAR modeling. Again, I know the framework I need. I know the explanations I need. So we resort to that as the first tool to solve with. Now, if these tools don't work, you resort to something else. But those are more interesting because you have AR models, you have MA models, you have differencing, which is the integration piece in there. And if you combine all those together, you can have a pure AR, a pure MA, a pure ARIMA, and then often you have to have exogenous variables. So now it's like an RAX, MAX, MAX, like a moving average exogenous model, a REMAX, which most people use. And then oddly enough, I almost always use a SARIMAX model, which is seasonal autoregressive integrated moving average exogenous model here. Now I'll write that on the screen for you guys. So this is SARIMAX. Again, this has all these parts and pieces. How many autoregressive terms? How many moving average terms? Are they canceling? We need to look at that. The integration piece, the differencing. How do you do the differencing? How many seasonal lags do you need on these sorts of factors? And then you have all the exogenous variables which go in, which are like your x1, x2, x3. This sort of thing is more on the structure side, but you still have structure you have to determine with the number of variables we're going to look at here in the logistic regression. So determining how many we have is going to be the structure piece that I was talking about. And then after you do all that, you still have to come up with the coefficients, right? I need my betas. So beta 1, beta 2, and then all the way out to beta n, right? Whatever structure we select. I need to get out to beta n and get those sorts of estimates. And then you start to get into things like p-values. And now, so for p-values, right, we're starting to test now, is that beta coefficient that we're estimating, is that significantly different, given the probabilities and everything, that it's different than 0, right? So if it's 0, then I selected the wrong model structure and I can drop those components here. So model selection in model definitions is kind of this process of research, because you're trying to figure out, how do I solve this problem? How do I define the dependent variables? How do I go about selecting the right model type? So I know for a fact I'm going to use logistic regression because I've done this so many times. But you could research and try out, decision trees, and you could try out, all kinds of other approaches that you want to kind of bring into this. And then finally, you have to do the research of, after you figure out what you're going to put into the model, then you have to get the coefficients of it. Then you have to do the statistical tests. Just like academic research, you should be going through all these sorts of tests. Every model has different theoretical tests to help clarify, or to help kind of support the idea that you have done the research correctly and this is the correct solution here, right? So again, you're going to have to do p-values, and you're going to have to do other sorts of testing, and then you finally come up with some sort of model here, and you'll end up with your final solution, which will have your coefficients and your definitions and your structure and everything else. Now this resembles a lot like, I'm going to say, like economic research, a lot of other research projects, in the sense that part of this is already predefined, right? I already have this list of cool definitions over here. And I'm already probably gonna have data. I'm at a smaller firm, so we often have to go find data. It's more like an academic pursuit. And then after you get the data, you do the modeling, right? Just like in economics or other fields, you're trying to determine relationships and what's causing things. So it's inferential statistics here. And then you're going to write this paper at the very end, not on the methodology, because I already know what logistic regression is, but the documentation should describe and explain the data, how you got the data, what's the data processing look like. And then you're going to have to go into this whole process of actually talking about why you chose logistic regression, why you did the testing. All these different components and pieces need to come in almost like an academic research project if you're doing this correctly. And I know many firms shortcut all the stuff I'm talking about because they're not real quants. But the banks have done a very, very good job, at least when I was there a few years back and a whole decade almost before that, from 2014 through, 2018, 2019, 2020, I think 2020, something like that. So about 6 year stint. But anyways, they went through and they have this academic-y process here. This is why I loved being at the banks. They forced everybody to do things very by the book academics. You had to follow the steps. You had to follow the processes. You had to document things. You had to justify why this equation, f of x, is the correct equation here. So this is why model development at firms, it's quick, it's fast, it's easy. We already understand the problem, but again, people move and shift and bounce around, and so we don't really understand, there's no solution to people, right? It's not something you can just model and find the answer to, and that sticks forever over time. People change. So quant finance is very hard because we're modeling people, and people aren't very predictable. Now let's go switch into this academic, more of an academic perspective. I'm going to call it like that deeper research. These sorts of projects, again, could raise from a variety of different questions. You could have the same question and go about the research process completely differently, because you're not under the gun to make a model that does rank ordering and accuracy, and it needs to be built within 3 months. And we need to hit production, and then we need to start scoring loans. We need to make money and do monitoring, and you're not in this grinding, kind of churning process here. So you're going to define your problem up front. Or more likely what you're really going to do, so we'll cross that out, you might be searching for a problem to solve. And so you might say, okay, Dimitri, your area is going to be time series, for example. and you understand the firm, you go to the meetings, you talk to the people, you're kind of involved in the business and the strategy, and you're involved in the discussions. Your area of expertise needs to be time series. You need to come up with a sort of idea or a process here. If you're working at like a buy side fund, so this is going to be investing, it might be something like come up with a strategy to make money. And so you just need to come up with something, right? It's kind of an open-ended problem here. You might have guidelines like you can only look at equity, so stocks, or it might be you can look at everything under the sun, derivatives, stocks, bonds, commodities, like doesn't matter, crypto, anything else. You can look at it, doesn't matter, come up with some sort of solution to make money. That is a very non-defined problem. It's why typically when you look at buy-side funds, many of them start to try to do more of the academic-y approach because they're not saying, hey, I want to model stock XYZ, go ahead and model this stock. And then you're, okay, well, this is a time series problem. Let me look at the different tools I have, right? The Box-Jenkins. Let's look at like, I don't know, LSTM models. Let's find some sort of, I don't know, Fourier transformation. And we'll come up with an idea and we'll test a bunch of them and we'll come up with a model to predict the stock price here. No. This is going to be a little more open-ended here. You might also have an example. Another example might be something such as explainability in machine learning models, or you might have, AI. You might have in here like a specific category, like maybe you have decision trees. But again, it's this open-ended process here, right? You feel like you're an academic, right? I'm back at school. I'm really excited to do research like a PhD, and I'm gonna sit down at my desk. I'm gonna read a bunch of books because you're crazy like Dimitri, and you pull out a bunch of these textbooks that you have sitting. I don't know if you can see on my other desk, I have textbooks sitting here. I have textbooks sitting here. I got textbooks everywhere. And you're just gonna read textbooks and come up with some sort of idea like an academic, and you're going to do the research here. Now, again, this is crucial and critical if the problem is very unique and defined. So if you do have this sort of defined problem, there might be a really challenging problem. So it might be something straightforward that everyone's already solved. Like for example, I don't know, portfolio optimization, but you say, but I want these sort of restrictions on this optimization. I want it to do these 5 things. And then people are scratching their head and they're like, well, I've never seen a model that does these 5 things. All right, Dimitri, quants, go out there and come up with some sort of solution for that. Okay, that's what you got to do. That's more of what you're going to be having if it's a defined problem. But again, coming up with these sorts of things is interesting. It's unique. The real big downside to this is, like, for example, I've created some fairly unique structures and modeling designs and methods and things. But most of my career is not doing unique academic research. It's often just doing the grind, the process that we talked about before, where it's like that model development thing, go through this process, and many people get frustrated and irritated, and they're like, I'm doing the same thing over and over again. But when you get into this piece here, when you come across a problem that nobody can solve, often like at a bank, it's a back of the mind problem. Like you're not going to get assigned to do it. It's just like, yeah, it's just there. It's not critical. We already built a haphazardly put together model where someone just threw this kind of thing together. But no. It's these sorts of problems at banks, for example, are quite rare. Again, typically not money making ideas here. Now, again, the investing side is probably more towards this because they're trying to get something more unique and cutting edge and whatnot. But when you do this, the downside to this as well is that often you cannot publish, right? So there's going to be no publications. Many firms are quite secretive around the modeling processes here. Even where I'm at now, we're starting to cut back and say, hey, this is kind of a secret process and methodology. Only Dimitri and a few other people are going to know this. We do not want to spread this idea out there because we think it has great value. Now, I put a lot of time and effort into coming up with the solution, understanding the problem and all that. But you're not going to have any publications, and it would be awesome to have a publication and people to challenge you. So part of a publication is, yeah, it's nice to have your name on a paper, and especially if it's something groundbreaking and something new, right? You get a nice, pat on the back. I feel great about myself. And then it's also great for hiring because people know that, oh, Dimitri Bianco, or I don't know, fill in your name. Say your name here. Your name is going to be on there that you invented or created something new that was revolutionary, that was groundbreaking. It makes you more employable, makes your salaries go up. It's this big deal here. But no, you're not often going to get a publication. And to be honest with you guys, even most of the things like that I've done that have been cutting edge or new or like more of an academic-y approach, they're not things that are like probably not earth-shattering. They're just things that are like, oh, it's never been done this way. We need to incorporate some new pieces into some sort of problem. Again, this method might only be meaningful for a certain handful of firms, but they could be huge and groundbreaking. I don't really know. It's really a unique kind of thing to do, but most people do not do this. Again, because it's not going to make money. Most of you are going to fail, or it's going to be something quite minor. And then also you're not going to get any publications here, which is also frustrating for anyone who's an academic because no one really cares. Like, you're here to make money for the firm, regardless if you're an investing firm or a bank or whatever. But I would encourage you guys to kind of take notes on your ideas over the years. I've built a lot of models and validated a lot of models and come up with a bunch of unique solutions, but I've never really written too many of them down. So anyways, this is kind of the difference here. Again, as we talked about, the academic versus the model dev. So I'm going to cross out academic. This is going to be quant research versus model development. This is really kind of the difference between them. You will probably do both. The skill sets are both. In my eyes, these are going to be called quants. Everything else, traders, these are business people, also quant devs. These are implementation teams, data engineers. These are also not quants. Quants are those doing the math. They are going to be the ones that essentially have f of x, find me this function, come up with some sort of answer to this. And again, the hardest part in mathematics is not churning through the calculations. It is defining the problem, setting up the problem, and then finally you come up with some way to actually do that solution. That is very, very challenging. Doing the number crunching, like, oh, I can do a derivative or an ODE or a PDE and find some sort of solution. Okay, cool. Like, not a big deal. But the hard part is actually setting up that problem, thinking of the theory, making sure it's correct. So anyways, thanks for listening. Thanks for watching. And as always, until next time.